Welcome to Creata classes. In this lecture, we will cover equilateral triangle. This is a special case. In this lecture, we will cover the line segment inside the equilateral triangle. Let's see what it is. First of all, let's take a equilateral triangle, that is the triangle with three sides as equal to each other. Here, let's assume the three sides of the triangle as A. This is an equilateral triangle, so all the three sides will be equal to A. Here, all these three angles will be equal, that is 60 degree each. We know the sum of three angles of a triangle is 180 degree. The three angles are equal, so 180 by 3, it is 60 degree. Further, we will study the line segments inside the triangle for an equilateral triangle. So for that, we have to draw the various line segments of the triangle that we have studied in the previous lectures. For that, let's make 4 copies of this triangle. Okay, we will draw the various line segments inside these 4 triangles. First of all, let's take the median. Median, we know, is a line segment that starts from the vertex of the triangle and it joins the midpoint of the opposite side. These 3 are the medians for this triangle. Further, in the second triangle, we will draw the angle bisector. These 3 are the angle bisector, that is, these 3 lines are bisecting the 3 angles of the triangle. In the third triangle, we will draw the perpendicular bisector. These 3 lines are the perpendicular bisector, that is, these 3 lines are bisecting the 3 sides of the triangle, as well as these are perpendicular to the 3 sides of the triangle. We got the 3 perpendicular bisectors also. Further, in the fourth triangle, we will draw the 3 altitudes. These are the 3 altitudes. These 3 line segments are perpendicular to the 3 sides of the triangle. We got all the 4 line segments of the triangle that we have studied. And all these line segments are with respect to an equilateral triangle. Let's join all the 4 triangles. Now the observation is that the thing that you are observing is that all these line segments are overlapping each other. It means that for an equilateral triangle, all these line segments are same. That is, medians, angle bisectors, perpendicular bisectors and the altitudes are same for an equilateral triangle. Okay, they are overlapping with each other. Got it? This is one of the important observation for an equilateral triangle. All the segments of a triangle are same. Moving further, if all the segments of a triangle are same, means their intersection point will be same. That is, the intersection point of median, the centroid, the intersection point of angle bisector, that is the incenter, the intersection point of the perpendicular bisector, that is the circumcenter, and the intersection point of the altitudes, that is the orthocenter, will be same for an equilateral triangle. All these points G, I, O and H will be same for an equilateral triangle. Got it? All these points are same. This is very important. All the line segments as well as the points inside the triangle are same. Got it? Moving further, now let's see the various properties and the formulas of an equilateral triangle. Let's take an equilateral triangle with the 3 sides as A. For this triangle, let's try to calculate the height of this triangle, that is the altitude. This is the altitude, and we know all the segments of the triangle are same, that is, this line is also the median as well as this line is the altitude. So we can say the median or the altitude or this line segment is dividing the opposite side into 2 equal parts. If this complete length is A, then these 2 line segments will be equal to A by 2. The median is dividing the line segment into 2 equal parts. Both of these line segments will be equal to A by 2. If we assume the height of this triangle as x, can we apply the Pythagoras in this triangle? We got A square is equal to x square plus A by 2 whole square. On solving, we got height of the triangle as A root 3 upon 2. This is the formula of height for an equilateral triangle. Or in other words, we can say this distance, that is A root 3 by 2, is the length of all the line segments of the triangle. Because in an equilateral triangle, all the line segments are the same. So if you got a question to find the length of the median of an equilateral triangle, then the length of the median will be equal to the length of the height of the triangle. The length of all the line segment of the triangle will be same, that is a root 3 upon 2. Further, let's try to calculate the area of the triangle. The area of the triangle is half into base into height. Here if we assume the base as a, the height will be a root 3 upon 2. On solving, we got the area of the triangle as a square root 3 upon 4. Okay, this is very important. The height of the triangle is a root 3 upon 2 and the area of the triangle is a square root 3 upon 4. Direct questions are generally asked in the competitive exam based on these two small formulas. So you should know these two formulas. Moving further, in the previous lectures, we have seen the various angles formed at the incenter, the circumcenter and the orthocenter. We have seen the angle formed at the incenter is 90 degree plus half of angle A, and the angle formed at the circumcenter is twice of angle A, and the angle formed at the orthocenter is 180 degree minus angle A. Here we know angle A is equal to 60 degree, that is all the three angles of a triangle is equal. Let's try to find all the three angles. Firstly, we will take the angle formed at the incenter. We got 90 degree plus half of 60 degree. We got the answer as 120 degree. Further, in the second case, the angle formed at the circumcenter is twice of angle A, that is 2 into 60 degree. We got the angle as 120 degree. Further, in the orthocenter, the angle will be 180 degree minus 60 degree, that is 120 degree. All the three angles are 120 degree. That again proves all the 3 points are same and all these line segments are same for an equilateral triangle. So we got the angle formed at the various point of an equilateral triangle is 120 degree. Got it? Moving further, let's try to find the inradius and the circumradius. We know the formula of inradius, that is small r is equal to area of the triangle upon semi-perimeter. And just now we have seen the area of an equilateral triangle is a square root 3 upon 4. And the semi-perimeter we know is equal to the sum of three sides of the triangle upon 2, that is half of the perimeter. And here all the three sides of the triangle are a. So we got the semi-perimeter as 3a upon 2. On putting these values, we got the inradius, that is small r is equal to a root 3 upon 6. Got it? This is the formula of inradius for an equilateral triangle. Further, let's try to calculate the circumradius, that is capital R, and we know capital R is equal to ABC upon 4 times area of triangle. And here A, B, C are the three sides of the triangle which are equal to A. And just now we have seen the area of the triangle as a square root 3 upon 4. On putting the value and solving, we got the circumradius as a root 3 upon 3. This is the formula of the circumradius for an equilateral triangle. We got the inradius as a root 3 upon 6 and we got the circumradius as a root 3 upon 3. Are you able to observe if we take the ratio of circumradius to the inradius, that is capital R to the small r, we got the ratio as 2:1. So we got the ratio of circumradius to the inradius is 2:1. That is, circumradius is twice the inradius. For an equilateral triangle, circumradius is twice the inradius, or the ratio of circumradius to inradius is 2:1. This is also an important observation. Let's try to plot the inradius and circumradius for an equilateral triangle. For that, let's draw the incircle and the circumcircle. So this is the equilateral triangle and this is incircle, the circle which is touching the three sides of the triangle. And this circle is the circumcircle. It is touching the three vertex of the triangle. The center point of both the triangle is same, as all the points are same for an equilateral triangle. This is small r and this is capital R. Are you able to observe? This line segment is also the median of the triangle as well as the height of the triangle. capital R plus small r, that is circumradius plus inradius, is equal to height of the triangle. And in the medians, we have studied that the centroid divide the median into the ratio of 2:1. Here also the ratio of capital R is to small r is 2:1. That is, this point is dividing the complete line segment into the ratio of 2:1. Here we are correlating this fundamental with the fundamental of the median and the centroid. Here if we add the circumradius and the inradius, we got a root 3 upon 3 plus a root 3 upon 6, which will be equal to a root 3 upon 2. That is the height of the triangle. So all these fundamentals are correlating with each other. Getting the fundamental, all these are in link with each other. Moving further, in the previous lecture, we have seen the formula of the distance between incenter and the circumcenter. That is, small d is equal to root of capital R square minus 2 times capital R into small r. Here d is the distance between the incenter and the circumcenter. If we apply the same formula for an equilateral triangle, where we know the circumradius is equal to twice of inradius. On replacing the inradius, that is small r, is equal to capital R upon 2, we got the value of d as 0. This again proves that the distance between the incenter and the circumcenter is 0. That is, they are the same point. Just for the comparison purpose, we have used this formula. The distance between incenter and the circumcenter is 0. That is, they are the same point. So these are the formulas that we have covered in the equilateral triangle. No need to write down the formula. Go to the download section and download these formulas. You will get the complete PDF of the formulas. So that's it for this lecture. Thank you very much for being with Creata classes. Bye for now.